Thank you very much. Let's get started. Okay, thank you so much for the chance to come here and share our work on the UMass ICONS program. I'm actually going to start with a question. And the question is, given uncertainty in things like the state of the climate, access to clean energy, and in some parts of the world, clean water or effective medicines, how many people here are concerned about the future? Me too. And the thing that's keeping me up at night, and so this is going to be a little bit different from what you've heard before, is that I'm not sure that we're training our students to be able to tackle these big, really multifaceted problems. So I hope that when I'm done talking about the ICONS program, which is a new educational program at UMass, you'll not only think about it as a great program for our students and your students, but as a kind of educational approach that's essential for our future. All right, and I was supposed to show you these really scary pictures so that you would raise your hand and be worried about the future, but let me move on. So ICONS, which stands for Integrated Concentration in Science, is an effort to bring these big problem areas, and of course we know this is one, really all of these are related to climate change. Big problem areas, areas of strength at the graduate level into the undergraduate level with a radically different way of teaching. So to start my story, I'm going to imagine that you're an undergraduate coming to UMass Amherst, and what you'll find is 25 or 30 really good majors, strong majors in STEM, science, technology, engineering, and math, each of which that does a fine job of training you how to solve problems that fit into each individual discipline. Obviously, this begs the question, what about the problems that don't fit? For example, if you want to design a new kind of bioenergy process, you're going to need to know something about the biology of your feedstock, something about the chemistry and engineering of fuel, something about the mechanical engineering and the physics of deconstructing them, and something about the mathematics and the data science of how to build models. So nowadays, unless you're Dan Nocera, who knows all of that stuff? Who's an expert in all of that stuff? And that's really the key question. The key driver for what I'm trying to get at here and for what I think is key to how we're going to get out of this is how are we going to train our future generations of students to really address these big problems. Now, one approach is called the interdisciplinary science major, where you take a couple courses from columns A and B and C and D. And right off the bat, you know there's a problem with this. You won't be an expert in any field. Good luck getting a job. And you probably didn't have experience integrating these ideas in service of solving a real-world problem. So this got about a dozen or 24 faculty together about a decade ago at UMass Amherst to address this grand challenge. How do we train our future STEM students so that they're not too narrow, stuck in their silos, and not too broad? And then it dawned on us that if a diverse team of faculty and staff is good for addressing a grand challenge, then diverse teams of students will be useful for addressing their grand challenges. And so the basic idea behind the ICONS program was born. So imagine that you had a diverse team of students, a biology major, say a physics major, chemistry, mathematics, engineering, whoever happens to be in the room, put them into a team and get them working on the big problems of our time, whether it's creating more wind energy, dealing with climate, dealing with water. The idea is have human diversity, train our students how to utilize human diversity, whether it's in terms of majors or whether it's in terms of perspectives on practicing the art of solving problems where the answer is not in the back of the book. So at this point, normally I show a video, but because I don't have as much time, I'm going to move on and share with you that we're in the 9th year of the ICONS program. The video, which shows you a little bit about what the ICONS classrooms look like, would have featured the first class. In addition, we now have the second wave, the third axis, the fourth dimension, the fifth element, sixth sense, seventh kingdom, eighth color, and the ninth bit. So we have more than 500 students who've come into the Icons program. They have many different backgrounds, many different majors, many different career aspirations, whether it's going into research, going into education, going into politics, going into government, going into business, whatever it is, they have one thing in common, and that is to become leaders in science and technology, armed with just the right kinds of attitudes, knowledge, and skills. So what I'm going to do for the rest of my time here is I'm going to share with you how we reach this mission, what are these attitudes, knowledge, and skills, what are some of the outcomes, and that defines, according to this conference, we have A plus B. That defines what I think is A. B, I'm going to ask for us to work together to create a global network where we're all working towards this kind of education. And to kickstart the process of making a global network, I'm actually going to hand out this sheet of paper and ask you to please, if you're interested in joining, to please put your name, institution, and a contact email address, and please hand that around so we can all start working together on this. So for the rest of my talk, I'm going to give you a concrete example of what a typical science lecture would look like and what an Icons experience is. I'm going to generalize that to an ancient philosophy, talk about the program goals and structure, talk about where we are now in terms of A, what are the outcomes, what's the network we have, and then dream big about B. All right, so here's a very typical, and is it okay if I move around here? I tend to move around. Okay, cool. So here's a typical lecture. How many people in this room at one point have taken some organic chemistry? Okay, few people, and at some point you probably sat through a lecture on sugar chemistry, where you went into some pretty serious detail on what's the definition of a sugar, what are some examples, lots of details on stereochemistry. I'm a chemist, so I'm a physical chemist, so I'm allowed to make fun of my chemistry colleagues. Maybe you talked about some of the chemical reactions, and maybe, just maybe, if you had some time left, you might have gotten to the applications. So this kind of way of teaching is very important because it allows you to go into content in depth. This is what I think of as a bottom-up. We heard bottom-up versus top-down in the last talk. This is a bottom-up way of teaching. There is a complementary way of teaching, and that is using a case study with the context of a real-world problem that has a who, what, when, where, why. So in the case study method that we use, students read something to give them some vocabulary about the case study. They come into class, experience an engagement question where they're forced to actually make a policy recommendation, or at least think about what they need to know to make a policy recommendation, do some research for the purpose of creating some deliverable, and then importantly, they reflect on what they've learned. So an example of how this would work that has some overlap with the sugar chemistry is shown here. So thinking about our local area here, New England, there was a study published in June 2010, rather controversial, on whether we should be using biopower, whether we should basically be burning biomass to create power. That received, in a short order of time, a response, many responses. Here's one, how Manomet got it backwards. So this is a juicy opportunity for students, and this could be even first-year students in college, to sink their teeth in to the reality of what some of the questions in energy. So they would read this before class, engagement, they would be faced with this question. Why different positions? And it's important, the engagement question is actually, even though this is a very open-ended subject with no right or wrong answer, it's important the engagement question is a yes or no answer, either or. So students are forced to take a stand and think about what would they need to know to back up that stand. So why different positions, which if either is correct. Now what we might do is we might assign them to design a new study that fixes a key problem. Now you can't fix everything, so you have to pick a subject. So for example, some students might like to focus on the biomass sources that were studied here and think about either sustainable forestry or even genetically modified organisms. Other students might be interested more in the bioenergy usage. This study focused on power. Should bioenergy be used for heat or fuels instead? Yet others, thinking about the last talk we saw, might want to focus on the CO2 accounting. So students get to actually dive in to what they want to study. And finally, they reflect on what they learned, why they learned, importantly, how they learned, and what would they do if they had to do it over again? So looking at these two very complementary ways, I want to generalize and realize that they're both important. We need content depth, and we need to learn how to apply our science and engineering in context. And so these are the typical kinds of outcomes that we see in the science and engineering courses that we take today, whereas this is the realm of unconstrained outcomes, where students actually choose the content and skills that they want to get. Because of that, it's very difficult for the faculty in the class to be the sage on the stage. They're much more likely to play the role of the guide on the side. That guide on the side role means that students are forced to construct their own knowledge, which is extremely transformative for our students. And so what this is telling you basically the philosophy behind the ICON's learning goals, which I'm going to show you in the next slide. Now in the next slide, there's a bunch of different learning goals. I'm not going to ask you to read them all, but it's important that we actually have a list of what are the kinds of attitudes, knowledge, and skills that future leaders will need. So we talk to faculty, we talk to alums, we talk to people who hire our students, and we came up with this list. And this is really the foundation. Identify components of societal problems appropriate for STEM study. Apply science concepts in context. It's surprising how hard it is for our students to actually do that. Utilize the human diversity on a team. Provide and utilize constructive criticism. We all know how hard that is. When we generalize, we see that this is about basically like a teamwork lab working on real-world problems, a communication lab where students are challenged to communicate in 360 degrees to scientists in their field, other scientists, and to non-scientists. How to do science lab on real-world problems, and then how to do research lab. And the structure here neatly fits a 4-year program. So this is the structure of the ICONS program. I want to emphasize this doesn't replace the major. All students in ICONS come from the range of 25 or 30 different STEM majors. Their major is the cake. This is the icing on the cake, or as some have said, the rum in the cake. So we take students as freshmen. People are shocked to think, how can freshmen be working on real-world problems that haven't been solved by the experts? Well, we can't wait for them to become juniors to start to get the attitudes and the courage to be working on these problems. They absolutely need to start to develop these attitudes when they're freshmen. Now in ICONS, we have 2 tracks, biomedicine and energy. So there's 2 sections of this course which focuses on communication relevant to the different fields, and 2 sections of this course where students focus on lab, energy lab versus biomedicine lab. So in the time that I have left, which is not much, I want to just touch on the essential aspects of a few of these courses. So ICONS 1, as I said, is basically open up the newspaper. There's no shortage of problems going on. Use the newspaper as the launch point for what the curriculum should be. We will do either 2 or 3 case studies. When we launched the program in spring 2011, cholera in Haiti and the Gulf oil spill were making all the news. Since then, it's been literally an A to Z of problems that we've been able to look at. And this is actually not even a complete list. And what we love to do, and also these are the create assignments, whether students are creating research proposals. Sometimes, for example, Zika, they created epidemiological models. And the very, very cool thing for the students was, because of the context we had in the class, they didn't turn that into the professor. It wasn't just another academic exercise. They actually turned them in to the CDC. So think about this. You're a first-year student in college. You're creating a model of Zika, and the CDC is very interested because you're going to have an out-of-the-box idea. What do the students say about this? What we find is that they find, for example, when we look at ICONS as the black bar and a comparison group of apples-to-apples classes, same size, same level as the white bar. So 5, 6, and 9, the instructor inspired interest in the subject because we opened up the newspaper and we asked students, what are the problems we should be working on? Instructor showed interest in helping, not the sage on the stage, but guide on the side. Instructor stimulated student participation. Where the bars are low actually reflects the pedagogy. So ICON's faculty don't lecture on material, and that's shown here. So instructor explained course material. If you've got 15 different teams in the class looking at 15 different aspects of a problem, there's no way one faculty member is going to be an expert on all that. And so that kind of re-levels the dynamics of the classroom. What's really interesting is item 7 here, which is low. I received useful feedback on my performance. Students are like flowers in the desert. They're thirsty. They have an unquenchable thirst for feedback when you ask them. So they've been going through K to 12, working on getting ready for their standardized tests. And then they come into ICONS and we ask them to solve a real world problem. And that is an attitude adjustment for them. And that's why we see this bar the way it is. At the end of the day, these green bars show that even though we don't lecture on material, we do stimulate student interest and participation. Students perceive that they meet or exceed their learning goals, but it's not a comfort zone. It's very much not. We get feedback like this. I absolutely love the freedom this course had to offer. You could literally pick what you wanted to study. Discussions in this class are more productive than I had on this campus. Often balanced with, there were unfortunately times of confusion. I sometimes would leave class not knowing what I had to do. Well, of course you do. Nobody knows what they need to do to solve these problems. So this balance is exactly the thing that we're looking for. Students feeling engaged, but actually feeling the discomfort of where the answer is not in the back of the book. So, yes. Close. Okay. Nice. So there's only 3 other courses to talk about, but instead I won't tell you about the ICONS 2 course where we help students to back design their own learning goals. We actually have students write proposals and we have a panel. So the students are writing for the opportunity to study the thing that they want to study. Only a quarter of the students will. So they learn that communication is important and bad communication has consequences. In ICONS 4, we have students actually create video communication products to act as abstracts for their work, because when they go into research, they dive into the rabbit hole and they forget that actually people in the rest of the world don't talk like they do in the research group. So we have to pull them back out of the rabbit hole. I was going to show you this video, but now I apparently won't. So in terms of outcomes, students are publishing papers, they're joining the Peace Corps, they're getting their first choice of jobs. Catherine Greco is at this meeting right now. That's the good news. The bad news is she's speaking right now, so I can't see her talk. There's an alumni network that's actually in 30 states and 3 countries trying to spread this way of learning. This has gotten a lot of press. This is what I call A. A is the ICONS network as it exists right now. We have academic partners, we have corporate partners, we have K-12 allies. You all know what that is. And this is the power to transform UMass. What we need is the power to transform the world. And so I'm hoping at some point we'll have a map like this, where each of these little buttons is something like an ICONS program spewing out students who are ready to change the world. So with that, now I will close and share a quote from Michelangelo. The greater danger is not that our aim is too high and we miss it, but that it is too low and we reach it. So I ask you to join me in this national global network. Thank you. Yes, please.
I'm sorry you had to rush you, but now we have time for a few questions.
Are those additional courses, so 12, 14 courses that they take throughout the year, that 4 year?
So that's an excellent question, and it's essential to the politics we had to play on campus. So ICONS is basically science rediscovering its engineering roots, meaning we need to have a mix of both engineers and scientists. There's no way engineers could take it if icons was courses over and above. So we had to meet with all 25 departments and do the politics of, if they take icons, what courses do they not have to take? And so we're able to work that out. The tricky thing is that, so we have, for example, the senior design projects for the engineering students counts as the icons 4, and that's crucial as long as it's done in a team and it's connected to solving a real world problem.
Because we tried it in senior design. I mean, many universities does that.
Yes.
But doing it from freshman all the way to the senior, I mean, that's a new concept. I mean, that's great.
Yeah, thank you.
Any other?
This is the interesting dynamic of if the student doesn't take a course in something that's super pedantically detailed, when they work on a real problem, they may not know they need to understand shell buckling. And then they'll design something and everyone feels good, and then the shell buckles and this other shit. And some people say it's more valuable. And then now we bring in the hot rabbit of the humanities classes.
Yes.
Because we have, fairly similar to most universities, you take 3 technical classes a semester and 1 humanities class. Icon seems to be a little bit of both. So maybe it's not just getting some class credit from the engineering side, but the humanities part needs to be involved and will give a little also.
So 2 points about that. The Icons 1 class is actually a general education class. Now, it's not a science gen ed, because none of the engineering or science students need a science gen ed, but it's an interdisciplinary gen ed, which is one of the boxes that they need to check. But the other issue is that, as we know, STEM alone doesn't solve these problems. We need politics, we need policy, we need economics, we need finance. How are we going to finance these solutions? So as the next step, we're entering into the 3rd chapter of Icons. We're thinking of actually opening up a new track in water and food. That's another massive problem area. And we're thinking that it makes sense that water and food as an experiment will actually be open not only to the STEM majors, but to several social science and business majors.
How was it?
One question in that.
What sort of regional association are you looking for? Like we have given you the number and
Yes.
what sort of what is the expectation from us?
Well, so what I would love to do is I'd love to talk to you about what your hopes, what your local hopes and dreams and aspirations are for how you would like to be teaching your students. I mean, the thing is that I would like to learn from you, and I think there is the possibility that we can learn from each other. Maybe you can learn from me. So we have created something at UMass. I'd love to, if anybody's interested, we're creating a new program where we're actually running workshops where we can work with your faculty on creating case studies based on the interests that you have in terms of your students and the research areas. So that's one thing that we could.
And what are the channels of regional knowledge transfer for that matter? Because so that
I'm sorry, I didn't
regional
understand.
knowledge transfer, what are the channels that you're using to maybe tap into that? For example, I'm from India.
Okay.
So if I want an icons program, so
Yes.
can I have a set of students sitting in India take the program?
Oh, I see what you're saying. Okay.
Or maybe if you're working on a problem that
Yeah.
is India specific,
Yes.
how do you then gauge the real life
Yes.
reality? which is-
Okay, so that's an excellent point. So one of the things that we've often thought of doing but haven't done yet is the fact is so all the problems that we often work on have a who, what, when, where, why. So it's important that they have a local context. And so for example, if there's a certain region in your country where there's a very specific, let's say, an energy pollution problem that you would like to study, then what we could do is we could have your students and our students working together on that problem. Our students would gain from that because they gain a global perspective that they don't have. Your students might gain just because of virtue of having a broader range of different attitudes and perspectives being applied to that problem. Okay?
Okay, I think we need to close now because we have a coffee break and we wouldn't like to miss that. We are scheduled to come back at 3:40, so we still have 25 minutes for the coffee break. Okay?